compulsory for all XE candidates. Engineering Mathematics. Section 1, Linear Algebra. Algebra of real matrices, determinant, inverse and rank of a matrix, system of linear equations, conditions for unique solution, no solution and infinite number of solutions, eigenvalues and eigenvectors of matrices, properties of eigenvalues and eigenvectors of symmetric matrices, diagonalization of matrices, Cayley-Hamilton theorem. Section 2, Calculus. Functions of single variable, limit, indeterminate forms and L'Hospital's rule, continuity and differentiability, mean value theorems, maxima and minima, Taylor's theorem, fundamental theorem and mean value theorem of integral calculus, evaluation of definite and improper integrals, applications of definite integrals to evaluate areas and volumes, rotation of a curve about an axis. Functions of two variables, limit, continuity and partial derivatives, directional derivative, total derivative, maxima, minima and saddle points, method of Lagrange multipliers, double integrals and their applications. Sequences and series, convergence of sequences and series, tests of convergence of series with non-negative terms, ratio, root and integral tests, power series, Taylor's series, Fourier series of functions of period 2π. Section 3, Vector calculus. Gradient, divergence and curl, line integrals and Green's theorem. Section 4, Complex variables. Complex numbers, Argand plane and polar representation of complex numbers, de Moivre's theorem, analytic functions, Cauchy-Riemann equations. Section 5, Ordinary differential equations. First order equations, linear and nonlinear, second order linear differential equations with constant coefficients, Cauchy-Euler equation, second order linear differential equations with variable coefficients, Wronskian, method of variation of parameters, eigenvalue problem for second order equations with constant coefficients, power series solutions for ordinary points. Section 6, Partial differential equations. Classification of second order linear partial differential equations, method of separation of variables, one-dimensional heat equation and two-dimensional Laplace equation. Section 7, Probability and statistics. Axioms of probability, conditional probability, Bayes' theorem, mean, variance and standard deviation of random variables, binomial, Poisson and normal distributions, correlation and linear regression. Section 8, Numerical methods. Solution of systems of linear equations using LU decomposition, Gauss elimination method, Lagrange and Newton's interpolations, solution of polynomial and transcendental equations by Newton-Raphson method, numerical integration by trapezoidal rule and Simpson's rule, numerical solutions of first-order differential equations by explicit Euler's method. Food technology. Section 1, Food chemistry and nutrition. Carbohydrates, structure and functional properties of mono, oligo, and polysaccharides including starch, cellulose, pectic substances and dietary fiber, gelatinization and retrogradation of starch. Proteins, classification and structure of proteins in food, biochemical changes in post-mortem and tenderization of muscles. Lipids, classification and structure of lipids, rancidity, polymerization and polymorphism. Pigments, carotenoids, chlorophylls, anthocyanins, tannins and myoglobin. Food flavors, terpenes, esters, aldehydes, ketones and quinines. Enzymes, specificity, simple and inhibition kinetics, coenzymes, enzymatic and non-enzymatic browning. Nutrition, balanced diet, essential amino acids and essential fatty acids, protein efficiency ratio, water-soluble and fat-soluble vitamins, role of minerals in nutrition, cofactors, anti-nutrients, nutraceuticals, nutrient deficiency diseases. Chemical and biochemical changes occur in foods during different processing. Section 2, Food microbiology. Characteristics of microorganisms, morphology of bacteria, yeast, mold and actinomycetes, spores and vegetative cells, Gram staining. Microbial growth age, growth and death kinetics, cereal dilution technique. Food spoilage, spoilage microorganisms in different food products including milk, fish, meat, egg, cereals and their products. Toxins from microbes, Pathogens and non-pathogens including Staphylococcus, Salmonella, Shigella, Escherichia, Bacillus, Clostridium, and Aspergillus genera. Fermented foods and beverages, curd, yogurt, cheese, pickles, soya sauce, sauerkraut, idli, dosa, vinegar, alcoholic beverages and sausage. Section 3, Food Products Technology Processing Principles, Thermal Processing, Chilling, Freezing, Dehydration, Addition of Preservatives and Food Additives, Irradiation, Fermentation, Huddle Technology, Intermediate Moisture Foods, Food Packaging and Storage, Packaging Materials, Aseptic Packaging, Controlled and Modified Atmosphere Storage, Cereal Processing and Products, Milling of rice, wheat, and maize, parboiling of paddy, bread, biscuits, extruded products and ready-to-eat breakfast cereals. All processing, expelling, solvent extraction, refining and hydrogenation. Fruits and vegetables processing, extraction, clarification, concentration and packaging of fruit juice, jam, jelly, marmalade, squash, candies, tomato sauce, ketchup, and puree, potato chips, pickles. Plantation crops processing and products, tea, coffee, cocoa, spice, extraction of essential oils and oleoresins from spices. Milk and milk products processing, pasteurization and sterilization, cream, butter, ghee, ice cream, cheese and milk powder. Processing of animal products, drying, canning, and freezing of fish and meat, production of egg powder. Waste utilization, pectin from fruit wastes, uses of byproducts from rice milling. Food standards and quality maintenance, FPO, PFA, AMARC, ISI, HACCP, Food Plant Sanitation and Cleaning in Place, CIP. Section 4, Food Engineering Mass and Energy Balance, Momentum Transfer, Flow Rate and Pressure Drop Relationships for Newtonian fluids flowing through pipe, Reynolds number. Heat transfer by conduction, convection, radiation, heat exchangers. Mass transfer, molecular diffusion and Fick's law, conduction and convective mass transfer, permeability through single and multilayer films. Mechanical operations, size reduction of solids, high pressure homogenization, filtration, centrifugation, settling, sieving, mixing and agitation of liquid. Thermal operations, thermal sterilization, evaporation of liquid foods, hot air drying of solids, spray and freeze drying, freezing and crystallization. Mass transfer operations, psychometric, humidification and dehumidification operations. Optional. Thermodynamics. Section 1, Basic Concepts Continuum and Macroscopic Approach, Thermodynamic Systems, Closed and Open, Thermodynamic Properties and Equilibrium, State of a System, State Postulate for Simple Compressible Substances, State Diagrams, Paths and Processes on State Diagrams, Concepts of Heat and Work, Different Modes of Work, Zeroth Law of Thermodynamics, Concept of Temperature. Section 2, First Law of Thermodynamics, Concept of Energy and Various Forms of Energy, Internal Energy, Enthalpy, Specific Heats, First Law applied to elementary processes, Closed systems and control volumes, Steady and unsteady flow analysis. Section 3, Second Law of Thermodynamics, Limitations of the First Law of Thermodynamics, Concepts of heat engines and heat pumps, refrigerators, Kelvin-Planck and Clausius statements and their equivalents, reversible and irreversible processes, Carnot cycle and Carnot principles theorems, thermodynamic temperature scale, Clausius inequality and concept of entropy, microscopic interpretation of entropy, the principle of increase of entropy, TS diagrams, second law analysis of control, volume, availability and irreversibility, third law of thermodynamics. Section 4, Properties of pure substances, thermodynamic properties of pure substances in solid, liquid and vapor phases, PVT behavior of simple compressible substances, phase rule, thermodynamic property tables and charts, ideal and real gases, ideal gas equation of state and van der Waals equation of state, law of corresponding states, compressibility factor and generalized compressibility chart. Section 5, Thermodynamic relations, TDS relations, Helmholtz and Gibbs functions, Gibbs relations, Maxwell relations, Joule-Thomson coefficient, coefficient of volume expansion, adiabatic and isothermal compressibilities, Clapeyron and Clapeyron-Clausius equations. Section 6, Thermodynamic cycles: Carnot-Whipper cycle, ideal Rankine cycle, Rankine reheat cycle, air standard Otto cycle, air standard diesel cycle, air standard Brayton cycle, vapor compression refrigeration cycle. Section 7, Ideal gas mixtures: Dalton's and Amigat's laws, properties of ideal gas mixtures, air-water vapor mixtures and simple thermodynamic processes involving them, specific and relative humidities, dew point and wet bulb temperature, adiabatic saturation temperature, psychrometric chart. Fluid mechanics. Section 1, Flow and fluid properties: Fluid properties, density, viscosity, surface tension, relationship between stress and strain rate for Newtonian fluids, classification of flows, viscous versus inviscid flows, incompressible versus compressible flows, internal versus external flows, steady versus unsteady flows, laminar versus turbulent flows, 1-D, 2-D and 3-D flows, Newtonian versus non-Newtonian fluid flow, hydrostatics, buoyancy, manometry, forces on submerged bodies and its stability. Section 2, Kinematics of fluid motion: Urea and Lagrangian descriptions of fluid motion, concept of local, convective and material derivatives, streamline, streakline, pathline and timeline. Section 3, Integral analysis for a control volume: Reynolds transport theorem, RTT, for conservation of mass, linear and angular momentum. Section 4, Differential analysis: Differential equations of mass and momentum for incompressible flows, inviscid flows, Euler equations and viscous flows, Navier-Stokes equations, concept of fluid rotation, vorticity, stream function and circulation, exact solutions of Navier-Stokes equations for Couette flow and Poiseuille flow, thin film flow. Section 5, Dimensional analysis: Concept of geometric, kinematic and dynamic similarity, Buckingham pi theorem and its applications, non-dimensional parameters and their physical significance, Reynolds number, Froude number and Mach number. Section 6, Internal flows: Fully developed pipe flow, COP1 empirical relations for laminar and turbulent flows, friction factor, Darcy-Weisbach relation and Moody's chart, major and minor losses. Section 7, Bernoulli's equation and its applications, potential flows: Bernoulli's equation, assumptions and applications, flow measurements, Venturi meter, pitot static tube and orifice meter, elementary potential flows, velocity potential function, uniform flow, source, sink and vortex, and their superposition for flow past simple geometries. Section 8, External flows: Prandtl boundary layer equations, concept and assumptions, boundary layer characteristics, boundary layer thickness, displacement thickness and momentum thickness, qualitative idea of boundary layer separation, streamlined and bluff bodies, and drag and lift forces.